All right, Mr. Robs.
And Mr. Cole?
And we're going to do linear inequalities. We're going to work backwards now. Now we're going to actually have to find what the linear inequality is. We're going to define the region that has L1 as its boundary, but does not contain the origin. And L1 goes through those 2 points, and it does not include L1.
Okay. Right. So what's the origin again? The
origin is the point 0, 0.
Ah, yes.
So we're looking to find, in order to do this, we have to find L1. How are we going to find L1?
Okay, so we need the line that goes through those points. So first we need to get the gradient between those points, right?
Okay. So I get my gradient or my slope. I do the change in y, so I'm going to go 3 minus 7.
y2 minus y1, yep. And then the change in x.
Negative 2 minus 4. So I get negative 4 over negative 6.
Which is 2/3.
Which is 2/3. Now, to find the actual equation, I like to use this form. Y minus y1 equals mx minus x1.
Okay.
Now let's choose this point for no good reason. Y minus 7 equals 2/3
x minus 4. Okay, let's multiply by 3. Get rid of those fractions.
All right, sounds good. I'll multiply this side by 3 and this side by 3. And I get 3y minus 21
equals
2x minus 4.
Okay. So we got 3y minus 21 equals 2x minus 8. And should we get the standard form?
Sure.
Okay, so I like to keep the x's positive and take away 3 y's.
All right, so we'll take away 3 y's. So I have negative 21 equals 2x minus 3y
minus
8.
And then add that 8. So we get, what, minus 13 equals 2x minus 3y.
All right, so I'll just turn it around. 13 with a negative.
Minus 13, yep.
Okay, so there is our line. And I know the region we're looking for does not include that line, and it does not contain the origin. So I really need to get a sense of what's going on here. So let's draw a quick sketch of this line to see what we have. So I have here, xy axis. Now if I'm going to graph this line, how can I graph this line? What are some of the approaches I can use?
Okay, so when x is 0,
okay, so
that's what I do.
The x-intercept, or the y-intercept. When x is 0.
When x is 0, y has to be, so we're going to have negative 3y equals negative 13. So we get y equals 13 over 3, positive.
Okay, that is approximately 4 1/3.
4 1/3, yep.
So I'm going to go over 0 and up 1, 2, 3, 4, and a little bit more. Here's the point here about.
Okay, and then when y is 0, we get 2x equals negative 13. So x is negative 13 over 2, which is negative 6.5.
3, 4, 5, 6, 7, so right here. So we know our line is going to go from here to here. Now it does say in the problem that the line is not included. Okay. So I'm going to use a dotted line then to show that. And so,
yep. Ooh.
There we go. Dotted line. And it also says that 0, 0, the origin is not.
Okay.
So that means I'm going to scratch away the origin. This part here I want.
So that's not included.
It's not included.
So which region are we defining?
We are looking for this region here. We have to think about what do we do for our absolute or our inequality. So if we do that, let's erase a little bit up top here so we can. So we want 0, 0 to not be included. So if I put 0, 0 into this equation, 2 times 0 minus 3 times 0 and negative 13. This is 0 and negative 13. If I put 0, 0 into my equation, do I want it to be a true statement or a false statement?
So we need that to be false.
We need it to be false. Well, 0 is bigger than negative 13, so I want it this way, because now it is false. So my region is going to be, where can I write this?
Running out of room.
Running out of room. I'll do it in blue. So my region, my final region, is 2x minus 3y less than negative 13. There's no equal sign because it's dotted. And because 0, 0
is false,
I want it to be a less than sign. That's the final answer.
Wow. A bit to do there.